In power system, sometimes it is very much necessary to determine the voltage, currents, and the kVA ratings all into a very convenient way of representation, that is called the per unit representation, in which the things which are actually on their base value are dimensionless, and they are easily computable by manual methods also. So we will be discussing about the per unit representation under some classes which under power system. So starting with the per unit representation, how they are expressed. It is expressed as the ratio of the actual value to the base value. So the per unit quantity is definitely equals to the actual value divided by arbitrary base chosen of the same dimension. So, if I say that suppose I is the current which is supposed to be the actual value which we have measured, and IB is the base value of arbitrary base which we have chosen. The same, since the base of since the dimension of current here, actual current will be amperes, here base current will also be amperes. So if I write like this, that I per unit in that case would be I actual value divided by I base value. So one can easily detect this thing, that since actual and base values dimensions are same, so I per unit quantities, always the per unit quantities are dimensionless. So per unit quantities are always dimensionless. In the same way, I can have V per unit also. If the V actual is the actual voltage and V base if we have chosen, so V per unit would be like this. In the same way, we can have the kVA rating also. So kVA rating are normally done on S, which is S. So I can have S actual value divided by S base value. So all these things, the current, the voltage, the kilovolt amperes, kVA ratings, all are dimensionless when they are in the per unit values. So coming to another part, when the power, how to determine the power in that case? We can have power as S is equals to, we are also determining power by S. S is equals to P plus J Q, where normally everybody knows that S is the apparent power, P is the active power, and Q is the reactive power. So how the P per unit can be defined? The P per unit can be defined as P, which is the actual value, which is in as watt upon the SB, exactly in the same way. Q per unit can also be defined as Q divided by SB. This is the per unit value of P and Q. Also, since everything which we are talking about right now is in the per unit, so we can also define the Z, which is the impedance. So if I am having Z base, so that will be what obvious equivalent to V base upon I base value. So which we have chosen the voltage base value, the current base value, that will be equivalent to the Z base. So we can have one more formula. SB will be equals to VB into IB. All these formula we have already studied in our elementary classes, but just to refresh that, just to brush up that, we are discussing them again. So we can have this thing also. We can have a derivation of the formulas also, since from here I can have IB is equals to SB upon VB. So I can have ZB as here, I can replace this by SB upon VB. So SB will be coming over here and VB square will be over here. So ZB would be equals to VB square upon SB square. So this is the way in which we are defining the per unit values and the phase values. So we can define Z per unit in a different way now, that is equal to the same thing which we have discussed previously, the actual value upon the base value. So the Z ohm suppose is the actual value. So I can have the ZB which we have discussed was SB upon VB square upon ZB. So it will be equals to VB square into SB. So this way I can take out the base per unit value of impedance by putting this formula as ZB into SB upon VB square. So one more thing will come with the impedance which we have discussed over here, 1 by the impedance is equal to YB. So I can have the L by B's formula also from this. I can have different n number of formulas from this. So I must remember all this formula. So the changing of base from one base to another base is a type of question which are being asked in examination. So these were the formula which we have discussed till now, but the basic formula which will be actually helping in deriving the different type of formulas. Normally the Z base problems are coming and the current base problems are coming in the per unit questions. So we can have the look on the Z base per unit formula in the change of base as well as in the current also. Sometimes what happens that a transformer or a generator or a line or anything, a transmission equipment is in its own per unit values, but when it is connected to a whole system, or when any of the system which we have discussed till now are connected on a power system. So previously, as we are knowing that its units are on the per unit units, but they are on their own basis. And now, since it may be possible that the base of the same has been changed, so how to change the base. That is one of the very important things which we should understand.